Alright, welcome back to Apex YouTube channel Houseplants for the entire world. So, in our first video, we talked about the architectural drawing and who is developing it and what are the conceptual background behind the architectural drawing and what are the legal backgrounds. So, after finalizing the architectural drawing, we need to do a fine, good structural analysis for the house design, and according to the structural design drawings, the construction need to be carried out. So here in this video, we are going to tell you about the things to be done by the structural engineer after developing the architectural drawing. So first of all, we'll take a look about the architectural drawing. Here, this is the architectural drawing. Now today we are going to discuss how the structural engineer need to develop the structural drawings for this architectural drawing. So here we have ground floor, first floor and second floor, and a very small house. So first of all, the structural engineer will come to your site and he will explore the site and he will find out the critical the conditions of the your land plot. So he will find out about the boundaries, boundary conditions, and he will find out about he will check about the existing buildings in your adjacent land plots, and if they have blind walls, and you have to consider about that, because if your building is also coming to an edge of the land plot, so when you are excavating for your foundations, so it will affect to your neighbors buildings foundations, and maybe sometimes cracks can be propagated in the already built buildings in your adjacent land plots. So illegally you will be responsible for that, and you will have to pay for that, or you will have to rectify it, or you will have to go to the legal actions or courts. So according to those conditions, by considering those conditions, structural engineer will propose a plan or method or special condition for your foundation types if it's needed. So he will explore the site first, and also he will ask you to excavate a pit with the dimensions 1 meter, 1 meter, 1 meter, or 3 feet into 3 feet into 3 feet. So he will come and he will investigate the soil condition, and he will check about the soil strata, and he will analyze about the soil condition available in your land plot. So I'll show you an image of test pit here. It's kind of this type of test pit, but here the depth is not much, but in the test pit depth should be 3 feet, and the side length should be 3 feet and 3 feet. And here from this you can clearly see the soil type. If there are so many type layers, various type of layers, he will analyze it, and he will assume a bearing capacity for the existing soil in your land. If it's a dumped or filled land, he will propose a special method to excavate it and refill it and compact it well, and he will tell you the depth to place your foundation bottoms. So it's very crucial, because your entire structure will be rest in these foundations, and the foundation will be rest in this soil. So if the soil is weak, it will badly affect your construction or house design. House can be cracked. Sometimes house can be tilted to one direction if there are different type of soils in your land, and it may lead to the differential settlements. So it will lead to cracks leaning the buildings. Sometimes buildings can be destroyed. Uh, the accidents can be happen. So it's very necessary. So if you have so many soil stratas, um, see here in this example, in your top layer you have woody forest litters. Uh, Actually, they are garbage. So that soil can't take any load. And then you have tephra layer and lowest soil layer and lowest enriched regolith layer and regolith layer. Likewise, your structural engineer will analyze these and he will tell you the depth. Usually pad foundations are placed in below 1 meter below as a practice. Otherwise, especially need to be designed. So according to the soil condition, he will design the foundations using your band capacity and foundation and everything. In order to design the foundation, you need the reactions from your building. That means the load path. You need to analyze the load path first, and according to the load path, what is the magnitude of the loads which are coming to a certain each column and each foundation, and according to that load and according to the bearing capacity of the soil, the structural engineer will design the foundation types. I'll show you an example. In order to find the reactions, first of all he will develop a computer building model. So in previous days they have just calculated by hand using tributary area methods, and now it's very easy to develop computer models and take the load it and take the necessary reactions for foundation. So I'll show you an example. This is the example. This is the 3D model which is drawn to the previously shown architectural design. And here you can see the plan views, foundation plan, and here this is the first floor plan, this is the second floor plan, and this is the water tank level, and this is the isometric view. I can rotate it and show you. You can clearly see the columns, beams and slabs. So they are already loaded with in the model. I can display you the line loads which are applied to the beams. Yes, you can clearly see the loads are applied in the beams here in the model. And also you can clearly see the loads are applied in the slabs. I can display it. Load design, shell, dead loads. Yes, you can clearly see the loads are the magnitude of the loads which are applied in these slabs. So the entire building is modeled using a computer software. Here what I am showing to you is ETABS 2016. It's a special purpose package of CSI made for especially high-rise building and normal building designs. So using this, people usually, the structural engineer can analyze the design, and they can clearly see, after analysis they can clearly find the reactions in the foundation. Yes, display force, stress and support reactions, and you combination ultimate apply. Yes, you can clearly see the reaction, magnitude of the reaction. According to you, using these reactions, the structural engineer will develop foundation drawings. So I'll show you a foundation drawing, structural foundation drawing. This is a foundation drawing. Pad foundations are drawn here. So for the previous architectural design, the structural foundation design is this. If we zoom to one single foundation, here you have C1 type column and F4 type foundation. F4 is 3 by 3 pad foundation. The depth of this pad foundation and the reinforcement requirement is shown separately. So it is F4 and F4 type footing. Dimensions are 3 by 3 and the thickness is 7 inches. And reinforcement details are T10 at 6 inches spacing in B1 direction, and in B2 direction is also the same. So typical section for this one is shown somewhere here. I can show you. This is a typical section for pad foundation. These are the two nets, B1 net and B2 nets are very clearly indicated. This is the column, and below the ground level the cover should be increased. Maybe it can be go to 2 inches because the reinforcement bars can be decayed when it react with water penetrating through this concrete, so the cover need to be increased. So this is a section, typical section of a pad foundation. And here also this one is a plan view of the pad foundation. The reinforcement bars are shown here and the reinforcement of the columns are shown here. So I can show you the entire structural drawing of this building, the foundation, the structural drawing of this building. So it's taking a small time, and here you can clearly see the other structural drawings. Alright, until they are loaded, I will explain how the slab loads are developed. So usually, when loading the slabs, structural engineers use two types of loads, the dead loads and the live loads. Dead loads are self weight of the slab, and when you do finishes or you put or lay the tiles and the tile weights, and if you put brick walls or something, so brick loads, all the dead weights are taken, self weight brick loads, finishes loads are taken to dead load. And for the live loads, live load is other one is live load. For the live load, they take if people are going onto the slab, and if they use it, the weight comes from the people or living beings is considered by live loads. It's an assumed value. In the relevant code of practices, those things are indicated, and by using those code of practices, structural engineers will use those loads and dead loads and analyze the structures. So this is a foundation drawing developed by a structural engineer. So here you have foundation layout. In the layout, for all the columns in the ground floor, the foundation details are shown, and the reinforcement and sizes are shown here in this table, and the sections are shown here. In this cage, all the details and all the notes are shown here. And if we put this type of pad foundation, the pad foundations need to be tied using tie beams, or differential settlements can be happen. So we provide tie beams in order to avoid the differential settlements, and it will avoid propagation of cracks. So entire house will act as a one single unit. That's why we provide tie beams. This is a tie beam layout, and you can clearly see a network of beams are going by linking each and every pad foundation. Yes, this is the tie beam layout, and tie beam details are given here. Here you can clearly see the tie beam. There are 4 T12 bars and a link. Link is provided. Link is R6 at 1 to 5, so it's shown here. So all the necessary sections should be provided in the foundation and tie beam drawings. So this is for external wall foundation with 9-9 beam, and this is for internal wall foundation with 9-9 tie beam. So there can be places tie beam is not going but a wall is needed. So for that places this wall foundation without tie beam detail can be used. And there are some places no walls but tie beam is going, so you have this detail. So this is the tie beam layout and wall foundation detailed drawing provided by the structural engineer. And also structural engineer will provide the column layout and the column reinforcement. In the column reinforcement drawing, he will provide the reinforcement required and the size of the column for each and every height or each and every level or each and every floor. So here you can clearly see you have C1 column here. Alright, from this column layout, the position of column can be taken. So this grid and this grid, you have column C1. So what is the detail of C1? And go to this diagram. C1, you have 4 such C1 columns, and from bottom level of the foundation to first floor level you have this section, and from first floor to roof terrace you have this section, and from roof terrace to water sub tank level you have this section. So you can clearly bind the reinforcement steel for column using this detail. So it's 40-12 bars and R6 at 5 inches stirrups. So there can be some variations according to the size of the column and the levels. These are some 14 columns, floating columns, which are starting from a different floor other than the ground floor. So this column is starting from first floor and this column is starting from roof terrace. So that means they need to be started from a beam. Alright, so this is the column reinforcement detail which is provided by the structural engineer for a structural design of a house. After that, the structural engineer will provide a general arrangement drawing. In the general arrangement drawing, the general arrangement of slab in that relevant level is indicated. In the general arrangement drawing, you can clearly see the beam arrangement along with the sizes, and also the slab sizes, slab levels. Here plus 11 feet means the level of this slab, and 5 inches is the thickness of this part of the slab. Alright, this dash line indicates that the slabs are in the same level. So here you can see a thick line. This means there's a difference between the levels of these two slabs. Yes, you can clearly see this slab B is in the 11 feet level, this slab B is 10 feet and 6 inches level. Alright, so the level difference is indicated using this thick line, and with this dash lines no level differences. So structural engineers usually give section of the general arrangements in order to clarify the condition of the slab and beams in that relevant area. So here in this drawing I have given section AA. What is section AA? Yes, I'm indicated it here. Section A is something like this: a 5-inch slab here in your right hand side of the beam, 14 into 9 beam, and left hand side you have 5-inch slab. So the levels are indicated. This will be easy for the contractor to develop or start construction works. Actually, the form work for to erect till the form work for beams and slabs. So the general arrangement drawing is necessary. And also structural engineers usually provide the beam drawings. So you can clearly see, so beam 1 9 into 12 size is given and the reinforcement details are given here, T2 T12 T2 T12. So 2 bars have to be put here, and here R6 at 5 inches. So this is the detail of the stirrup. The stirrup should be laid from this point to this point, and the level of the beams are given. So this is a beam drawing which is developed by the structural engineer for a structural design. So we have so many beams. So we have 3 beam drawings, and also 4 beam drawings, and this is a slab structural design drawing. Here you can clearly see the general arrangement of the slab, but this is not the general arrangement drawing. This is a slab drawing. That's why it indicates the steel arrangement to be placed in the slab. So you can have you have this bar with these dimensions from this place to this place. This shaped bar should be laid from here to here, and the details of that bar is indicated in this arrow, end of this arrow. So detail is T10 at 9 inches. This means this bar is made of T10 and the spacing is 9 inches. And B1 means this bar should be laid in the bottommost layer in this direction. And what is this 20 inside the bracket? It means the total length of this bar is 20 inches. Likewise, you have the entire steel bar arrangement, rebar or reinforcement bar arrangement of the structure. And this is the slab drawing which is provided by the structural engineer for construction. And the structural engineer should provide the roof drawings if they are available. So the contractor should follow each and every advice and note and direction which are included in the structural designs, and always when construction is going, each and every part should be according to the structural design and structural drawing. So it is very much necessary for the economy and the strength of the building. So in the next drawing we will discuss so many things about the construction, building models and everything. Until then, please be with us. Subscribe our YouTube channel for further good videos about house plans and construction and everything. Share us our videos for others to increase their knowledge. So until our next video, bye for now. Good day to you.